What exactly is a moderation? Well, before we get into the conceptual framework around this question, let's make a quick note on terminology. For the purposes of this class, the terms moderation and interaction will be regarded as synonymous. Now, there are some who would disagree with this. There are some stats experts who make the case for some fine-grained distinctions between these two concepts, but we're not going to go there for this class. For this class, we're going to treat them as the same thing. In both cases, moderation or interaction represents a conditional effect, namely that we have a main effect of a predictor on an outcome, and that main effect will vary in some way based on values of another predictor, called a moderator. So the nature of the relationship between two variables will change as a result of another variable coming into the mix. So the logic of moderation poses this question: what is the relationship between x and y? Is it strong? Is it weak? Is it positive? Is it negative? And the correct answer is that it depends on the moderator. So this may invoke an illustration of external validity, for example. External validity questions are always questions of moderation. So we want to understand, does this particular relationship between x and y generalize across various settings, across various participants or units, or across various treatment types? We may be curious, for example, if a certain intervention still has the same effect on the DV that we originally saw if we tweak certain aspects of it. If we make a 1-hour training a 2-hour training, will that impact the outcome, for example? If we change the way that the material is presented to the participants in this intervention, will that change? That is an external validity question. It's tied to construct validity as well, but the overall idea is this idea of conditional effects. Okay, so does a relationship between a predictor and outcome hold, or does it change? Is it fluid across different situations? Another example for the that's in the I/O world is this example of intelligence predicting job performance. I don't necessarily like the body of research around this, but there is a whole body of research around this question of intelligence of an applicant predicting their future performance on the job. And we know that this is an effect that holds more or less across all jobs because we have meta-analytic data that says this. The implications of this I won't get into, but for now let's just think about the stats behind it. So there's this positive relationship between intelligence and job performance, but this relationship varies across different industry sectors. So we know that some jobs require more cognitive ability than others. Some jobs require complex thinking and problem solving to a greater degree than others. And so we know that there's a moderation going on. That for some jobs this relationship will be very strong and positive. For other jobs it may be weaker or even drop to 0 and not be a predictor anymore. That is, cognitive ability will no longer predict job performance. A moderation produces a joint multiplicative effect between two predictors on an outcome. A multiplicative effect basically says that the relationship is not additive. You can't add the effects of a predictor 1 and the moderator to get the combined effect on the outcome. So I like to think about this in terms of pie and ice cream. So if you're hungry right now, I apologize. But pie and ice cream together are way better than they are separately for some folks. Okay, so let's just assume that this is the case. And it's not an additive effect. Let's say we eat the pie alone and we add our pleasure, kind of rate our pleasure for that. And then we eat ice cream alone and we add up our pleasure for that, or indicate that. And then we add those two together. So we have the pleasure of pie eating alone and the pleasure of ice cream eating alone. We add them up and we assume that if we put the pie and ice cream and eat them together, that total value will indicate the pleasure that we'll get from the combination of the two foods. And that is an additive effect. So when we assume that these two things, we can add them together and get the pleasure indicator, that is not a multiplicative effect. That's an additive effect. A multiplicative effect would say that we can't add those two amounts of pleasure together to get how we would feel if we ate the two foods together. When they are together, we experience a whole new level of pleasure that is not additive. So it's multiplicative in this case. Okay, so that means that we get more pleasure from eating the pie and ice cream together than we could if we added up the pleasures of eating them separately. And so that's really what a moderation does. There are three types of moderation specifically. First, there's a synergistic effect, and this is when the main effect of x on y is enhanced under conditions of the moderator. So this is like the pie and ice cream illustration that I just delineated. So we get a greater feeling of satisfaction having them both together than the additive effect of both of them alone, each of them alone, I should say. A compensatory or antagonistic effect is when one predictor cancels the other out, or the moderator can cancel out the predictor. For example, high ability can compensate for low motivation, and vice versa in graduate school performance. Okay, but you need to be high on one of the two. Let's say being high on both doesn't give you any extra performance enhancement. So that is, again, a theory. Let's put aside for now the trying to figure out if that's actually correct, all right, if there is a compensatory interaction there. But let's assume that this theory is correct and that we only need one of the two. We have to be very high on just one of them in order to do well in graduate school. So we can either have very high ability and lower motivation, or we can have very high motivation and a little bit lower ability, and we're still going to get by fine. Being high on both doesn't necessarily do anything extra in terms of our performance. And finally, we have the buffer effect, which is in a lot of studies. You may have this in your 2YP or have read this in a journal, and that is that the main effect of x on y is lessened under conditions of the moderator. So in the presence of the moderator, the relationship between x and y either falls to 0 or just becomes weaker. And this is a good example of this is stress. So you can have the relationship between stressors in your life, difficult circumstances, and then the stress that you feel, but we would expect that to be buffered by social support. So to the extent that you can have people in your life who listen when you have problems and are able to provide you help and able to provide a listening ear, you would expect that this would mitigate the stressful impact of those circumstances on your well-being. All right, so that is conceptually what a moderation is. Remember, it is not an additive effect. An additive effect is what we see normally in regression, with just adding up various main effects on the DV of interest. But this is something different, and so we're going to be switching gears here in this class and thinking about things in terms of additive versus multiplicative effects.